Good afternoon, everybody. We'll get started. It's 2 minutes after two. My name is Tony Davitt. I'm a solutions architect working in Cisco. I've been with Cisco for the last 13 years and working in security for a bit longer than that as well. I'm here today to talk to you about our security architecture and how we believe we're doing security different, and that we need to do security different to solve some of the challenges our customers are facing. I would encourage you to post any questions in the chat window, and we'll do our best to answer them on the call. I'll leave a few minutes at the end to answer some of those questions. If not, we can follow up with them as well. So without further ado, I'll delve into the presentation. So I suppose the first thing to really recognize is the security landscape is drastically changing. The modern workplace itself is continuing to actually create conditions that actually favor the attackers. And speaking of the attackers themselves, they really have evolved quite drastically, I would say, over the last sort of 20 years. Moving on from sort of the days of what you would see in movies, as I'm sure you well know, in terms of sort of script kiddies, as we used to call them, and so on. It is now purely and simply a business. It is as simple as that. They estimate anywhere between $400 billion and $1 trillion in terms of potential revenue, for choice of a better term, that these guys are actually trying to access. You know, in terms of, they have also got far more sophisticated in the way they actually do their business. Even from a perspective of, you know, they do things like telephone support. The last thing I actually saw was, which I thought was actually quite funny and with to some regard, is that we've all heard of sort of software as a service, infrastructure as a service. We now have ransomware as a service. You can actually contract people to actually run a ransomware campaign on your behalf, and they will take a portion of the actual proceeds or profits from that campaign. It has got to that level in terms of an actual business. They're also doing even other sophisticated things like actually field testing of malware. So before they actually will release the malware in earnest, they will do field testing of it. And if you actually think of these types of concepts of, you know, as part of ransomware, they usually ask you to pay by Bitcoin, because obviously it's a way of getting the cash in a fairly secure and anonymous way from their perspective. And if you don't have a Bitcoin account, they'll offer you phone support on how to set up a Bitcoin account. So we look at these things, they're actually really truly operating as a business in terms of testing of their product, rolling out of that product in a sort of a beta version first, offering telephone support to their customers. I'm doing bunny ears here that you can't see me in terms of their customers. So, you know, the landscape from a point of view of attackers has drastically changed. At the same time, the applications that we're using within our businesses today has also fundamentally changed. You know, from the day of, just using email to communicate with internal and external people, to lots and lots of different mechanisms now in which we actually communicate with our customers. And also, you know, a lot of us, as you're well aware, a lot of those applications obviously moving to the cloud infrastructure, which also has a knock-on effect in terms of the actual applications that are going across our network as well. And when we start to use cloud-based services, we have a tendency, for right reasons, to encrypt that traffic. And internally within Cisco, we see approximately about 60% of all of our traffic going across our network, both internally and going externally, is encrypted. We estimate by about 2 years' time that would probably have hit 95%. Also, with things like TLS 1.3, which actually prevents you from doing a man-in-the-middle of attack. Now, you might sort of go, that's a good thing, and it absolutely is a good thing, but it also stops us actually decrypting that traffic, inspecting it, and then re-encrypting it and sending it on its way, because essentially that is a man-in-the-middle of attack. So it's becoming also then, with advances in encryption, it's becoming harder to inspect that encrypted traffic. And from our threat intelligence operation, which I'll come back to in a few moments, we also see that about somewhere around 15 to 20%, it varies on a day-to-day basis, but around 15 to 20% of malware is actually distributed in encrypted mechanisms today. And so the hackers, the bad guys are actually copying onto that fact, obviously, and spreading their malware in an encrypted fashion as well. At the same time, devices are changing on networks, and I don't just mean sort of the whole BYOD thing and using phones and tablets to access applications, but just even in terms of if you had bought a machine 20 years ago, it would absolutely be a desktop. Now, I'd say the vast majority of PCs being purchased are laptops, the vast majority of them. And an awful lot of them don't even come with Ethernet, of course. They come with just wireless, and you have to go and buy a dongle if you want to have wired in it and so forth. So the devices themselves are changing. And also the spread of those devices are also changing too, in terms of it's not just those PCs and phones and tablets. We're also then integrating sensors and IoT devices. And the challenge there is that those devices are not they're not usually, in fairness, built with security in mind. Security is absolutely an afterthought on those. Usually it's around, especially sensors, usually the thought is battery life and memory and making them as small as possible and not putting in security built into it. So the landscape itself is changing, and it is causing us an awful lot of challenges to be able to secure that environment. In a lot of cases, a lot of corporate devices don't ever even touch the corporate network and just go directly to cloud services. So securing them is becoming a challenge. But don't worry, the industry has you covered, as we say. This is not with disrespect to any of the logos that are on this slide. It just really is trying to make the point that actually the security market is so fragmented. What we've done in the past as organizations to try to secure ourselves is we pretty much, not always obviously, but we pretty much react in terms of we have an issue with a certain thing, whatever it happens to be, whether it be receiving too many spam emails or something, or my current solution isn't fit for purposes anymore. It just hasn't evolved because I bought it 6 years ago. And what do? I go out and I look for who's the number one in the top right hand corner of some magic quadrant or something along those lines, and I will buy that product. And that will absolutely solve my problem from an anti-spam perspective. But the challenge is that the more and more I do that, I then have to manage potentially 50 different vendors with 50 different management platforms for those 50 security products. And none of those products talk to one another or integrate and share information with one another. And as I said earlier on, the attackers have evolved, and they're no longer, there's always stuff in the background, but the newer attacks are sort of a multifaceted attack and not just trying to come in a certain way and yes, my email detection will always catch that. It's usually done in a much more layered approach, and an awful lot of times a single device is not capable of spotting that attack in isolation. So we have a number of options in terms of trying to solve this challenge of this changing landscape. Well, we can do the same thing again and again. I think somebody defined it. It is sometimes said to be Einstein, but as far as I know, it's an unknown statement of doing the same thing over and over again and expecting different results. So we can carry on buying point products, and we'll solve some of the challenges, but we certainly won't solve all of them. As another famous intellect said, if first you don't succeed, give up. I don't really believe that to be an option. Or what we can do is we can actually change how we do things and actually understand our enemy better, if you like. Rather than him taking us to the field, we'll take him to the field, if you like. And I think that is the way to change it, and certainly that's what we believe here as Cisco in terms of that. And it's an integrated approach and an architectural approach, which is something that's different on the market. And we believe that's the way that we're going to solve this problem. Really, again, just sort of make the same similar point again, and then the attackers are relentless. They will keep on looking for chinks in the armor, and they have evolved. And yes, there are target defenders out there, but in a lot of instances, they're for the example, but they're using nuclear weapons when we're still using an axe, basically, right? And it's not a fair fight. So we really need to do things differently and have that, as we believe, an architectural approach. So just want to talk about sort of, in an ideal world, what would it actually look like? How do we solve this problem? So let's say at time zero, we have some sort of an incident, if you like, or a potential vulnerability. Something is actually trying to break into my network. Well, what's the actual best case scenario for that? Well, obviously, the first thing you need to do is actually detect. Detection is still key. And there are lots of ways of doing detection. You can base it on signatures, you can base it on anomalies or behavior and so forth. So there's lots of different ways in doing it. But you have to obviously understand that, that really comes first in terms of that detection phase. However, the industry standard, or the industry average, my apologies, but the industry average for time to detection is actually somewhere around 100 days. And that is just not good enough by anybody's stretched imagination. And in an ideal world, you would obviously have that down as close to zero as possible. And that's what we call the time to detect. So in an ideal world, incident happens, detect it straight away and immediately. The next thing obviously would be, if we do detect it, we obviously need to contain it and stop it actually spreading across the network. So pretty much T is equal to zero, detection, and then after that, contain that attack, stop it progressing any further into the actual network, and get that device maybe off the network into a quarantine zone, and also do that in an automated way. And that's also something we're traditionally not good at, I think, as a security industry in terms of that automation. An awful lot of systems we will just alert on it, and not exclusively again, but an awful lot of times we will just sort of send a syslog message to say we have seen this and we've tried to block it, or we've detected this attack. It's still in place, but we've actually detected it and we're telling you about it. And then what we do is we'll send that syslog message off to some other system, if you like, which will maybe join all those other syslog messages together and then present that. And all the while, data is leaving the organization. So we also need to get more familiar, both as organizations and also, more importantly, as vendors, to actually do more automation of security. That if we actually see somebody on the network sending malicious traffic across the actual network, remove that device from the network dynamically. And then obviously, once if an attack has happened and something has been compromised, whether it be ransomware down onto a PC or data loss, to be able to recover and understand, first of all, if I did lose data, what did I lose? Because obviously with things like GDPR and so forth coming, well, it's there already, just enforcement in the not too distant future in the next couple of months, you will actually have to inform of exactly what happened and exactly what was lost. And then obviously recover from that loss or from the ransomware or whatever it happens to be. So that to me is what sort of a best case scenario looks like. And if we can shorten the times between all these different sort of typical areas of an incident happening in terms of that detection, stopping it, and then recovering it from it, if we can get that down as small as possible, that to me is the best case scenario. However, excuse me. Unfortunately, though, at the same time, an awful lot of people still sort of see security as a blocker in organizations and actually not and stopping innovation within the network. And I think the key point here is really that what we need to really think of is security needs to be at the foremost of every project and every business thing that we do as organizations, and not an afterthought. And that is typically the way it can be. That we will design something, whether it be, I don't know, a new website or something like that. And once all that is done, then it's like, okay, how do we secure it? Well, actually, no, security should be at the table right from the very, very start and built into the actual solution of whatever it is that's happening within that organization. And I think that doesn't happen enough. It does happen sometimes, but it doesn't happen enough in organizations. Our belief is that to get that best case scenario in terms of that reducing that time to detection, reducing the time to contain an attack, and reducing the time to backup, the only way you can really do that is through an architectural approach. And one of the key aspects of an architectural approach is threat intelligence. If you can't see it, and you don't understand what's out there, how can you possibly detect it and being up to date? So the more you can see when it comes to threat intelligence, the better at it you can be. And our threat intelligence is called Talos. We are the largest threat intelligence team in the market. I know probably some of you may be thinking, well, actually, other people say that too. But the one thing I would say about it is we actually publish our numbers in terms of what we actually see. Not all others do. To give you some sort of examples of the type of levels of data we see 16 billion web requests a day. I think that's slightly out of date. Actually, I think it's about 18 now. Put that in context. Google see about 5 billion web requests a day. Now, I know we're doing slightly different things, but just in terms of the volume of traffic that we see of where people are going in terms of websites and locations on the internet, we see a vast, vast volume. We see about 600 billion emails, messages a day, and that equates to around 35% of the global email traffic out on going across the internet, which is a huge percentage of the emails. And again, that gives us an awful lot of data around who's sending out, phishing attacks, who's sending out spam attacks, what news sites are popping up, and so forth. Also, we see about 18.5 billion AMP queries a day. What that is basically detection of malware, and that's ones that we know about. We also sample about 2 million unique files a day in terms of looking out for new malicious code going across the internet and into customers' networks. But another real important point, though, is that all this information is shared across all of our endpoints in that architectural approach. And sometimes you'll hear us talk about sort of detect once and then protect in many. So if we get information from one source, we can actually send that information down to lots and lots of different products, which I'll come back to that point in a few moments. So just in terms of what have we done around our time to detection, and here's some of our figures, or what we have actually got it down to. The Cisco annual median time to detection is actually 4.6 hours. And as the industry average is actually 100 days. So we really have been focused on getting that time to detection through that threat intelligence right down. And at the same time, in the last year, we've seen a tenfold increase in the observed threat samples that are out there. So whilst we're seeing more, we're also there's a direct correlation actually with getting that time to detection right down. And also another key aspect of our strategy is around that cloud-based security, both offering systems to protect our customers from the cloud, but also to protect the cloud services themselves as well. So it's kind of a two-pronged attack, which means that you can protect your cloud-based services and at the same time to be able to deploy new services really, really quickly from a security perspective. So this slide here kind of sums up what our strategy is and what we're doing and what do I actually mean when I talk about an architectural approach. So the first thing that we've actually gone and done is we've broadened our portfolio. So we've gone on a major acquisition path in the last 4 years, and we've acquired a number of companies. We've also invested a significant sum of money into internal R&D for new products, and also for the development of some of our existing products that we have to keep them up to date. And as I say, we're broadening that portfolio all the time. And at the same time, though, we also have a realization that actually we're not going to play in every single area of the security IT market. So what we've also done is we've actually set up a number of alliances with lots and lots of different companies in the security space, some that you would probably traditionally think as our competitors, and that they can also integrate into this architecture as well. And that's what I mean by this integrated architecture. Anytime we purchase a company or develop a product, it must integrate into that cloud-delivered intelligence that I talked about, that Thales organization. It must integrate into that, and it must integrate into our other products, and also be open so that actually other non-Cisco products can also integrate into that same architecture. And I'll give you a couple of examples of this in a couple of moments. Actually, I'll give it to you now. So this slide here, what we're trying to show here is just an example of sort of the architectural advantage in action. So what you're looking at here, basically over on the left-hand side of the slide, you will see sort of, HQ there, and typically you'd obviously have an next-gen firewall. We would have maybe a web security appliance of some sort. We'd have an email security appliance, or maybe some wireless infrastructure, or even cloud-based security infrastructure as well. They can all integrate into a company, a product that we have called Umbrella. It was formerly known as OpenDNS, if you're familiar with that. And Umbrella basically offers protection at a DNS level, but also at an application layer as well for web-based traffic, and integrates into all these products that you see on this slide, but also integrates into our roaming clients, as we would call them. So in other words, if you have a user that is very rarely on the corporate network, they're out and about over VPN, or maybe even going directly to services, we can cloud-based services, we can also protect them using Umbrella. So then how Umbrella works at a high level is that it'll block them out. it integrates with Talus from a DNS level. So Talus feeds in the threat intelligence information into the DNS request. But at the same time, we also can redirect users to a proxy where we actually want to analyze the traffic going through the systems so that we can actually protect the traffic in real time. The interesting point, though, is that as we get more intelligence even from those systems, we can feed that down into other products, such as our firewalls, such as our IPS, such as our malware protection. So it means that you have a secure internet connectivity. You have connectivity for other applications that use DNS as well, but also all that information is then shared across multiple products, so that if they spot something, going back to that, detect once and protect in many places. Also, this is the cloud-based services, and you can actually have this provisioned globally in, it's as a matter of minutes. I have had a customer only recently as well that were actually under attack, and we had this deployed in 1.5 hours. From the time he actually contacted me with a problem to actually getting an order on the system, getting it up and running, and actually getting it configured was literally 1.5 hours, and that is a genuine example. So because it is a cloud-based service, we can get this deployed really, really quickly. So I would encourage you to have a look at Umbrella, but it's just one example of an integrated approach. What we can also do, though, is with that information, if we do spot that somebody has been infected and they're actually trying to communicate out to a command and control server, we will obviously block that from that communication happening through Umbrella. But we can also then feed back into the actual network and go, this user who you granted access to the network is actually trying to communicate out to a command and control server, and then you can actually change that user's policy on the fly, automated, and remove that user from the actual network. And as another example of that integrated approach. Security needs to start becoming more effective, fairly obvious statement. But the way in which we're achieving that is, first of all, trying to make it simple. For too long, the industry, I think, has, as point products have, and including ourselves and some of our products, has given our customers data and not knowledge. And there's a big difference between the two, especially when it comes to try reducing that time to detection. It needs to make it simpler to understand in the information that we present, and don't just present data, present actual information or knowledge, and do that in a very simple way. And make it simpler to also deploy security services on network, whether they're on-prem or cloud-based. We, as an industry, we need to be open. Systems need to be able to share information with one another, whether it's from vendor A to vendor B or from vendor A to vendor A. It needs to be more open in terms of sharing that information. Having 50-point products with 50 management platforms really isn't going to be able to detect the new attacks that are coming, are already there and coming in the future from the bad actors, as they call them. And we also need to take a more automated approach to security. If we see something, take an action, get that device off the actual network. So that's our at a very high level, our effective security strategy across those three. In terms of just some recommendations, I'm not going to go through all these 7 actions. I'll put this in really for your reference. This is from our annual security report that we publish each year. And at the end of it, it gives a number of actions. And really the main point that 2 points I want to make on this slide is that security really needs to be led from the top, in terms of there needs to, the board need to understand security, push security in every aspect of the actual business. But in terms of the actions, things like, education, adhering to policies, review those policies and practices, back up data. These are all things that are actually nothing to do with technology. They're to do with processes and things that we can do within an organization without actually going out and even buying new technology for that matter. And we need to start doing these things as a matter of urgency, and also getting that more integrated security architecture led through cloud-based intelligence, or backed up by cloud-based intelligence. So that was what I had in terms of slides. I don't know whether Una, there's any, or Chris, there's any questions that you want me to answer at this point in time.
Hey, yeah, from Novasu's point of view, I think this has been quite a useful exercise, seeing what the infrastructure developments coming along are and what the changes are in the last number of years, because it really does seem like it's changed quickly. How do you foresee it changing again in the coming years? I mean, what's coming down the line from your point of view?
I suppose there's a number of different things really that we've seen. The one key point that it will always come back to when it's sort of what's coming down the line is asked is really where's the money? That's what it really comes down to. In terms of the attackers are looking for ways of getting at the cash, at data, whatever that happens to be. Like if you look at things like, you can buy a Facebook account for $1, you can buy a social security number for $1, you can buy a credit card data for anywhere between $1 and $60 on the internet. So anything that gets money. Some of the later advancements that we're kind of seeing from a technology or malware perspective is in ransomware is the biggest single revenue generation piece of malware that we've ever seen on networks. And what we've also seen lately is that an awful lot of ransomware has been delivered in some new mechanisms. Traditionally, ransomware came in via email that you were sort of sent in a piece of code that would then download the ransomware and affect only that machine. We're now seeing a lot of ransomware actually doing network spreading. So actually going east-west, if you like, within organizations from PC to PC, or also to things like hunting out network drives and trying to encrypt network drives, not just actually encrypt any local drives and so on. So there's a lot happening around ransomware and it becoming more and more sophisticated. We're also seeing one of the latest things we've also started to see more and more of is using legitimate services for malicious purposes. And what I mean by that is that the hackers will try and use cloud-based services that are there and very legitimate businesses, but actually host their actual services in those locations unbeknownst to the actual cloud-based company itself. And they are very, very hard. Like they'll actually put their command and control server in a infrastructure as a service type company. And that company takes a while for that to be detected. And all the while they have a live command and control server. So there's things like that happening because, and the reason why they're doing that is it's very hard to shut that down. Obviously, you can't put in a rule that blocks that whole infrastructure as a service company. And you just can't do that. And so actually trying to detect those types of new command and control services is very, very hard, and also trying to shut them down is very, very hard when they use legitimate services for malicious purposes. And they are a couple of things that we've seen over the last while.
One thing that Novasco's been working on quite a lot recently, and Amplify is a company we partner with, is on cloud application discovery. So sort of understanding what is in use, what people within an organization are accessing or using regularly. Is that something that's within Talos is coming up a lot, or within the Cisco as a wider company?
Yeah, I don't want to make this sort of a product pitch really, it was more about the architecture, but yes, we do have a product as well called CloudLock, which protects your existing official cloud-based services, and also can look at what cloud-based services are being accessed from your internal network that you may not have actually, or you may not even know is being accessed by users as well. So all those sort of shadow IT, I think as the marketing term goes, of those cloud services as well. So that is something that absolutely we can do. And yes, Talos would have information about all those different services that are out there and rate them as well. Just on that point, one other thing that we're also seeing, kind of related to this question, but also their last question, is there's an awful lot of sort of DevOps type behavior that we're sort of seeing in organizations as well, that organizations are using infrastructure as a services companies, that they will spin up a server, do some testing, and then actually leave it live, and potentially that service has access back into some resources internally in the network or into some other cloud-based services. And an awful lot of times when those DevOps bring up these services, they're not secured properly either. I came across one customer that actually had a full replica of his AD server sitting out in a DevOps server completely unsecured with no password. And that is a genuine example that when we're doing testing, sometimes we don't think of it as the same level of security as we would if it was a production system. But the challenge there is that there is information there that can be actually gained and then used against the production systems, if you like. So it's sort of another aspect of that sort of shadow IT, but specifically around DevOps as well.
Well, for me, this has been great, and I'm sure for the listeners, it's been great. If anyone wants to pop any questions using the GoToWebinar tool, there is a questions section there. If you want to drop some in there, or alternatively, if there's nothing at the moment, you can email a question in. Well, send them in to ourselves, and then we'll pass them on to Tony to marketing@novasco.com. We'll get back to you with all the wisdom we can muster. We'll leave it a couple of minutes there, Tony, just to see if any questions pop up.
Sure.
But other than that, do you want to say farewell to those that are leaving?
Yes, indeed. Yeah, thanks very much for your time. Hopefully you found it useful, and appreciate your attention. Yeah, I saw one question coming through there from somebody around ASA firewalls and can we decrypt SSL traffic for inspection? It's an interesting one because there's many answers to it. So the short answer is yes, we can decrypt SSL traffic. Some of our boxes, without getting into the detail, do it in software, others do it in hardware. Obviously, hardware is more efficient and you'll get higher throughput based on that, and that's why the hardware decryption is there. So yes is the short answer. However, that is becoming a bigger and bigger challenge, not just for us, but for everybody on the market in terms of, as I say, TLS 1.3 will stop that actually happening. You won't be able to do it if the client is using that. And that's the first challenge. The second thing is that as more and more traffic becomes encrypted, decrypting it doesn't become feasible. You have to buy such big boxes to be able to do it, that it becomes very, very costly to do. So interestingly, we've also just released a new technology as part of our latest switching portfolio that actually has the ability to detect malware within encrypted traffic, but without decrypting it. Now that solves a number of challenges. It solves the problem from a compute perspective. It also solves the challenge from a point of view that you can no longer be a man in the middle of attack in a TLS 1.3 and forwards. So it solves both of those challenges. And how we do that is actually through our threat intelligence and some clever analytics in the background and machine learning to be able to say that encrypted session there is benign, that encrypted session there is malware or malicious, but without decrypting it. I'd have to do another 30-minute webinar to go into the detail of exactly how that works, but that is a new feature as well. So interesting question. Just see another question coming through there around SIEMs. No, we don't play in the SIEM market. We do partner with a number of SIEM vendors. I think they're pretty much the top three in the right-hand magic quadrant. Splunk, Curator, and Logarithm are the three main ones that we actually partner with. And when I say partner with, what that basically means is that when those devices receive a syslog, say from a firewall saying this IP address tried to reach this IP address and was blocked by rule 52 or whatever the case may be. And what it can do is it can integrate into our identity services engine, which is a product that basically keeps track of all devices and the state of those devices on the actual network. And then what we can do is the SIEM can integrate into that and actually say, I have this IP address, can you tell me who's logged into that IP address, what device it is, and where it's located. So now within the actual SIEM window, it can go, Tony David using his MacBook up on the third floor, tried to access this system and was blocked by rule 5 of the firewall or whatever the actual incident happened to be. So that's one where we can give more context to other third-party systems through that integrated approach. So I hope that answers your question.
There's one more question there, Tony, if you want to get that, and then any follow-ups we can do via email.
Sure. Yeah, again, we have a product called AMP for Endpoint, and what that has the ability to do, it is a client on an endpoint that actually will look at files coming in and out of that device sample them through a hash function first and foremost to see if it's a known piece of malware. But at the same time, for any stuff we don't know, we can send that file for sandboxing, for testing to see if it is a day zero attack. And in addition, then we can also look out for if that file does land on the PC, because maybe there's no other further information about it. We can actually see if it performs any malicious behavior on the client and block those behaviors on the actual operating system as well. And interestingly, we've just announced that we actually have that for iOS devices as well, called our Security Connector and Clarity. So we're doing that both from a traditional operating system perspective, but also from mobiles, and specifically Apple in this particular case. Okay. So I think, Chris, we'll leave it there then. And if there's any other questions, sure, I can follow up via email. So thanks, everybody, for your time.
Awesome. Thanks. Bye, Tony. Bye, everyone.